While we wait for the slides, I'd like to say super excited to be here. I think the future of construction, or lack thereof, is filled with many friendly faces and past colleagues and acquaintances. So I look forward to that future. I think from some of the things that we've heard, one of the most important factors that we need to maintain moving forward is malleability. And I think the future of construction requires us to be malleable, and I think it requires us to be malleable all the way into the construction process, and that requires us to have tools that work robustly and work on-site. And at Gravis Robotics, we essentially do that. We make on-site construction robots. They do things like this. You have a high-level goal, dig a foundation. You have a machine that works fully autonomously with online perception, looking with LiDAR sensors to understand the environment and work and dig and excavate without any human intervention. We do this essentially with a little box that we put onto any machine. It's equipped with IMUs, LiDARs, GNSS, all the necessary infrastructure we need to turn essentially any construction vehicle, any hydraulic excavator, into a computer-controlled robot. So we've all been familiar with industrial robots. This essentially gets that technology out onto the field. We've done this exact same box deployed on a number of different machines, and we're expanding that fleet quite consistently now. One of the challenges with using these very large tools, if you've never used one before, is that hydraulics aren't the same as electrical systems. You have this multi-stage hydraulic valve, you have a pilot stage, a main stage. This introduces a bunch of dead zones in the control loop. You have complex kinematics that aren't done in a perfect ABB factory that differ between models and manufacturers. You have a single power source that's pumping all of these hydraulic lines, and so you get coupling effects. If you move your boom and your stick at the same time versus one separately, you get a different behavior. You have temperature oscillations, you have cylinder friction, you have variable operating conditions. All these things make things very, very hard to control. Of course, some of you who are thinking about the future know that the way that we solve these problems nowadays is using AI. And that's our core strength. So we essentially take any machine, we let it run automatically, we collect some data to understand the dynamics of that machine, and then we use those dynamics to create a massive simulation model. So we have both mass kind of sim model, mass real data collected in a kind of short burst of time. And we can combine these things to then directly deploy to a machine to do construction tasks like grading, 3D trajectory following, and of course, the most important thing for an excavator, excavation. And here, I think what's very important is that much better than even some of the most experienced operators, we can feel, using the pressure in the cylinders, the dynamics of the soil. So the same input to the machine here is not a trajectory input, it's a goal input. Fill the shovel with dirt. Here, the soft soil, the machine digs one scoop. Here, where there's a hidden boulder, the machine drags gracefully along the top of the stone and then digs deeply into the soil when it gets beyond that. And of course, this amazing control of machine can also be done for fun things. I think in construction, we're still allowed to have fun. Of course, if someone finds a market for this, please let me know. And I had to put in here that this technology is something that came out of academic research. My own work was together with Gramazio Kohler Research in the Robotic Systems Lab, and using this exact same machine, this exact same hardware setup, we built the largest robotic structure using reclaimed materials that currently exists. So this wall consists of almost 1,000 irregular boulders and reclaimed concrete pieces that were built using this autonomous platform. Get a sense of the potential there. One of the things that I'd like to end with here is a kind of an understanding of the way that we work. And if you know my past work, you'll see that I'm not fully focused on just autonomy, but also on the people side of things. So here we do autonomous operation, but to bring autonomy into the construction market, everyone is always trying to solve 100% autonomy. And what they do is they pick a task that they can 100% automate. I have an amazing robot that can do all these different things, but I can only paint a 1 meter square. So now let's find the market for painting 1 meter squares, and we do that 100% autonomously. From day one, we expect that the operator is going to intervene here, that they're going to be informed and understanding of this autonomous system, and that if autonomy is only 10% of the time, that's okay, because we have an in-cab interface and a remote interface that lets people drive and control this machine, and we have a number of semi-autonomous tools that let people quickly gesture an input to create a terrain profile to be able to command a machine intuitively and quickly. Moving forward, we have kind of two ways of working. Basically, we see if the duty cycle of autonomy is anywhere less than 50%, You essentially keep the person in the machine, and you augment them with this kind of knowledge that you get from these LiDAR sensors. So beyond the machine being able to dig autonomously, it maps the environment, it creates a real-time survey, and it tells the operator what area is too high, what area is too low, to where they can work with efficiency and accuracy that avoids material waste and lets them work quickly. And at any moment, they can turn on a button and say, now autonomously dig within this rectangle. As that duty cycle increases, we get people who can step away from the site, who can manage 2 machines, 3 machines, 4 machines, 5 machines, and that is essentially how we grow, is through leveraging that experience of operators and gaining in the way that we can kind of gamify and automate that experience over time. So that's us. Thank you.
On point. Thank you very much, Ryan. We may also have to challenge the rule 8, don't dig, what we saw in the keynote before.